Welcome to Inside Tech by MediaTek, your source for deep dives into embedded and consumer technology. This episode, MediaTek VP of Computing Platforms PD Rajput joins Moor Insight's principal analyst Anshel to explore how MediaTek is powering the next generation of computing, from the DGX Spark personal AI supercomputer to the rise of edge computing.
Hi, I'm Anshel, and joining me today is PD Rajput from MediaTek, representing the computing group. He's the vice president of the computing group. And I wanted to talk to him today about some of the computing paradigms that are happening within the industry. Thanks a lot for joining me, PD.
Thank you for having me here, Anshel.
I kind of wanted to kick things off by asking about what are some of the biggest AI computing trends happening right now, and how do you see those evolving in the next 5 to 10 years?
You know, Anshel, we spent a lot of time looking at this and thinking about this, especially it determines so much of our product and our long-term strategy. A few things that at least we see. Obviously, inference is becoming the largest computing workload that the industry has ever seen. Even the legacy software, which used to be non-AI based, traditional algorithms, are getting retooled to be powered by AI. Really, the querying is getting added into all of the legacy software as well. So inference is really revolutionizing not just the new software, but even the legacy software. So that's really one. Second is we see the rise of efficient language models, particularly in open source, as another key trend, and which has huge implications. Obviously, we have seen OpenAI launch GPT OSS 20B, 120B. Google has Gemma, which is their open source language models. The rise of small language models, particularly in open source, is another one. The third will be this rise of balanced and efficient architectures. And we are proud to be part of creating this trend in the industry with our partners, with products like GB10. These are the products which are balanced in terms of CPU, GPU, and memory bandwidth, and having the right trade-offs for a very efficient and performant AI architecture for the edge. So with these three trends, it has huge implications. We see inference will come out of the cloud and be pervasive across all the different compute locations, all the way to the edge devices. And it has huge benefits overall in terms of economics, cost, privacy, availability, and performance. And we can talk a lot more about that. But those are kind of the macro trends we are seeing, which is driving a lot of our own strategy.
Yeah, that's great. I was going to say, you talked about some of the benefits. Could you maybe talk more about how edge computing and some examples of use cases where local processing is beneficial?
Just take an example of finance department at any corporation. The earnings are going to come out, the quarterly earnings are going to come out. You want to be able to analyze that in-house. And a lot of that has to be local. If there is AI or models that you can use locally to analyze your financial data in-house, that's key. You cannot be kind of porting that to the cloud. Healthcare has HIPAA requirements. All of that has to stay local. All of the intelligence you have to process should be local. Same thing for legal topics. Attorney-client privilege requires you to ensure that this data remains local, and any type of intelligence has to be done locally. And then there are many other kind of examples. Imagine a mission-critical use case inside a factory where the environment is such that there could be outages, but for these type of mission-critical programs, that is not an option. So you want AI to be happening locally even without the internet. So those are good. I personally am most bullish about the potential of voice as a true assistant, a true agent for you on your devices. And we see a lot of potential for voice-enabled PCs doing a lot locally and truly becoming your co-pilot and your assistant driving your workflow. And I think those will be pretty key in driving some of the new use cases we see.
Yeah, you mentioned GB10, which is inside the DGX Spark family of desktop PCs. How do you see devices like the DGX Spark changing what's possible for LLMs at the edge? Because I've had a lot of fun using it, and it's actually been the most fun I've ever had with using AI at the edge. So I'd love to hear your thoughts.
That's excellent. It's great to hear, Anshel, that you're enjoying using DGX Spark. Obviously, we are proud of our partnership with NVIDIA, and we have co-developed and co-designed this chip GB10, which is inside the NVIDIA DGX Spark. There are multiple types of use cases, and Let's start with training first. When we look at a full training cycle, particularly for language models which are a certain size and below, say 200B and below, a lot of the work that actually happens is in pre-training and also in fine-tuning. The production run of actually training the whole model is a subset of the full cost that you actually pay to simply do pre-training and fine-tuning. When you do all of that in the cloud, 50 to 70% of your time is actually spent in setting up the cloud, VMs, provisioning, getting a workload going, and then doing these pre-training and fine-tuning exercises. And only a portion, very small portion of your total OpEx is actually used in the production. And this is especially true for a language model below a certain size. If you could do all of that locally on your desktop, on your workstation with a device like DGX Spark, and you have time frame of 6 months to a year to do something like this, where you want to keep experimenting, fine-tuning, we have done lots of TCO models, and it makes complete sense to use a model or device like DGX Spark to do that type of work. So it kind of enables this hybrid environment, an AI loop between cloud and your workstation. And a lot of the development should happen on the workstation. And if the software stack is consistent across cloud and this device, it just is a dream come true for a developer who's doing something like this. And this is where NVIDIA's leadership in the software stack across the GB architecture in the cloud and GB architecture on Spark makes it all seamless for the developer. So that's the training story. And by the way, this is a huge community. I'm not going to say a certain number of million developers in the world, but the number is pretty large. We see a huge community of users, developers, researchers, scientists working in this type of a workflow. Second is inference. Personally, for me, if I imagine, if I had a personal assistant who or digital assistant rather, who knew everything about my choices, about how I work, about how my personal day-to-day is, and is actually a true personal assistant, I would prefer for that assistant to be local rather than be in the cloud. And if a device like this can host that assistant for me, because these can support up to 200B type of models, if an expert assistant can be stored locally on this device, it can be a personal AI hub for me. And then all my local devices, my phone, my laptop, my TV, my general home appliances can interact with this AI hub and make a true AI personal environment around me. That is another inference type of a use case. So that's the second. And even for service providers, right? If they can host their service locally at the end user, they don't have to manage the CapEx or the infrastructure that actually comes by supporting these services in the cloud. It's a no-brainer. The end user pays for the hardware once, and the service provider makes money from their software. They don't have to manage the infrastructure. So a lot of this makes total sense, even from an economic standpoint. So we believe this is the start of a revolution in the edge AI. And I think we all believe that edge AI is the next frontier.
Yeah, like I said, I'm a big fan of what the DGX Spark represents. And one thing, I use a lot of GPUs in my day-to-day, and those are pretty power hungry. So I was curious if you could tell me, like, how efficient is a DGX Spark versus, other inference or training solutions?
Yeah, I mean, it's a 1 petaflop of performance all within a full device, which is about 240 watt, and the chip itself is about 140 watt. It can plug into your standard wall outlet. Imagine this kind of performance. You would require kind of like a mini data center type of an environment to plug in just a few years ago. And this is amazing thanks to NVIDIA and their amazing technology leadership and our partnership with them. We are able to bring this kind of technology in a workstation form factor.
Yeah, and you mentioned inference and training, but what are some of the ways that someone might be able to take advantage of DGX Spark specific to certain industries or applications?
Yeah, I would just go back to my other use cases that I mentioned earlier, right? Finance department at any corporation should be using it to analyze their internal finance data. Same thing for healthcare, insurance companies or hospitals doing analysis on local data, legal departments in the companies. I believe those are the same use cases that apply here. And obviously, the developer community is out there. I mean, we are looking forward to see what magic they can create with this.
Yeah, I was going to ask, do you see any future applications, next gen, evolving industries that might benefit from it that aren't legal or medical?
So there's a lot to be discussed when we talk about edge AI. It's not just legal, medical, healthcare. like I mentioned, as language models become efficient and open source becomes a thing, the economics make sense for a lot of AI to happen outside of the cloud. And that opens so many possibilities. There are many locations outside of the cloud. There's obviously on-prem data centers. There are edge servers, which are sitting inside a branch office or a telco edge, like in a base station or in a sports arena or a retail location. These are efficient, small racks, sometimes just edge servers, which need to be power efficient, cannot be loud because they're sitting in an office. So those type of deployments. Then there are obviously pro PCs and workstations. So within the whole edge server space and the pro PC space, there are lots of possibilities we see today. Going back to the edge server example, you see that a lot of the offerings that we see getting deployed are kind of a standard data center class CPU with a standard AI accelerator. Could be an NPU or could be another type of an accelerator, discrete accelerator. And those are not optimized for edge locations. Imagine in a branch office, you have these big, high power, huge fans running servers just to run some local AI that you want to, and it's not convenient. The power efficiency, the architecture, the cost are not optimized for that location. We believe Spark creates this interesting category where suddenly devices like this, which are power efficient and performant and support the AI stack, are suddenly the new type of an architecture that helps service this location better than any other solution has in the past. And we believe there is an opportunity for this to grow meaningfully.
And moving beyond DGX Spark, what are other computing innovations that you're excited about?
So generally across the computing space, there is a lot going on. In fact, it's interesting. I was just thinking about it the other day. In 2019, Dave Patterson, while getting his Turing Award, mentioned we are entering a golden age for computer architecture. It cannot be more true. We've seen this over the last few years and it continues. We've seen the evolution of NPU, especially in the PCs, how NPUs are suddenly a first-class compute engine in your PCs. And that was not the case for decades before that. And they are enabling a huge new type of use cases. So NPUs, along with GPUs and CPUs, is one. I think we have seen the role of memory kind of even get bigger and bigger. Obviously, I don't want to undermine what memory stands for, but it really used to be compute drives the performance. But now with inference and with inference time reasoning, how you balance your choices on memory bandwidth versus compute has a huge implication on the final product. So now it's about balanced technologies in the computing platform that you have. That's at the silicon side. Because of so much compute coming in, the chiplets architecture is pretty much the standard now, which leads to advanced packaging coming on to your standard client architectures. So that's new. Moving up hardware to software, language models are becoming the new platform. In fact, we see that the OSs themselves are bringing inflow AI, integrating SLMs as part of the standard OS, which actually is leveraging these unique IPs that we have in our silicon. So that's at the platform/OS level. And then at the application level, there is a lot of innovation too to enable this type of use cases. We have seen the rise of co-pilots and assistants. Some of the examples we've been seeing are obviously in coding agents, which today also mostly run on the cloud. But with the rise of MCP, Model Context Protocol, enabling an efficient way for applications to talk to local data on your PC and the local model on your PC, we see a breakthrough that could happen for local AI. And I will keep going back to how much potential voice has to become your true assistant in your day-to-day PC workflow, be it for personal or for your enterprise use case.
Yeah, and you brought up SLMs as part of the operating system. So, I want to talk a little bit about PCs and what are some of the innovations you're seeing in that space?
Let me break it down into two parts. One is happening from the silicon and the OS side, and second is from the OEM side. So I talked about silicon and OS, right? We talked about these heterogeneous architectures, advanced packaging, and we talked about how OSs are even kind of becoming more smart and enabling these agents as part of the standard platform. On the OEM side, it is finally an era where OEMs have an opportunity to differentiate. Traditionally, in the PC ecosystem, generally the machines have been differentiated by battery life, form factor, display quality, and OEMs have taken leadership based upon their channel strength, their enterprise relationships, their ability to service their customers. But from a technology standpoint, power has been held back into the platform, which is OS and silicon. AI is finally opening the doors where there is an opportunity for OEMs to differentiate based upon their own use cases. They can customize the models on the devices based upon their target user. So that's one. So I expect OEMs to hopefully start differentiating even more at the use case level. Secondly, and this is what we believe, we really excel. MediaTek has this DNA of building custom platforms for our customers, and we kind of make bespoke products. In this golden age for computer architecture, we see a future where OEMs and where the customers would be looking to build even custom silicon, not just custom software for their differentiation. And that is a journey we are looking to be part of with our OEM partners.
You talked about custom silicon, so I'd love to hear a little bit about what are some of the considerations that go into designing an AI chip for whatever platform it might be.
I go back to my early days in this industry when we were on this cadence of we have the CPU and we have the GPU, but it's really all about the CPU, and let's just keep improving performance generation over generation, and then the Moore's law would ensure that there is like an exponential factor to improvement of that performance, and software would just run better every year or every 2 years. The world is a lot more complex now, and it's not just about improvements in CPU or adding a feature here or there within the CPU architecture. It's about ensuring what are you building this silicon platform for, and what are the choices you need to make for it to be the right platform for that use case. So it's a choice between CPU, GPU, NPU, and memory. And how you make those choices has a huge implication on the cost. And I'll talk about the cost a little bit more. Those balanced trade-offs are critical. They can make or break your product. And if somebody makes a wrong choice today and silicon comes out 3 years later, which is generally the time frame, the industry would have probably been very different. So there is dynamics in which we work with where the choices today could be wrong for the silicon coming out in 3 years from now. And how do we ensure future proofing in this? And software is changing so dynamically that these trade-offs are very complex to make right now. We look at that as one vector. Second is where the software is going to be in a few years from now. Third is, I talked about cost. I think cost, in my opinion, is playing a hugely important role now in how we are looking at our roadmaps. And with the rising production costs across the supply chain, we cannot just keep making chips more expensive. And there's a lot of innovation happening in business models and choices on what goes on the most expensive node versus what can stay back on the previous node, and what is the right kind of a cost profile for our customers. So third is the cost. And I have to add this fourth angle, which is the methodology, the mindset that you have in developing this chip. If the system software, the drivers, the tools, the working with the developers is key, because if the world shifts within the 3 years of silicon development cycle, your software will be your savior. So how you are able to use the software or have a hardware-software co-design methodology to ensure that by the time this platform comes out, you have been able to use software effectively to get the most out of your chip while still being a leader in the new paradigm that you're launching this chip in. So across these four vectors, it's a complex set, but this is where all the fun is, and all of these are considered as we not just define the product, but execute the product all the way to launch.
In the process of making all those considerations, how does MediaTek work with its industry partners to deliver that success and execution?
I feel very proud to be part of MediaTek. We have a lot of great technology in the company. That's what has led to our leadership in the smartphone space and in many other areas where we are number one, including ARM-based Chromebooks. We have a leadership NPU, CPU, GPU technology and implementation in these products. When we look at going into a market and we believe that this market, we can differentiate only if we partnered rather than built in-house, we are very open to that type of a mindset. That brings our partners along with us in the journey and helps everyone. So as part of that, we make some choices very upfront that, hey, this is where we're going to partner, and this is not where MediaTek's own IP will fit. And we are very open to that. So, and in that, we work with our partners on new business models or partnership exploration on how the two companies can build something together. So this could be just a development type of a partnership. Obviously, on the software side, And we have some examples like that. We have announced our partnership with NVIDIA on the NVIDIA Tau Toolkit, which is bringing NVIDIA's IoT software and model innovation on MediaTek IoT platforms. And that is the best way to accelerate our own entering that market. So we have done that. Same thing with NVIDIA on the G-Sync side, where we have brought in their technology and software onto our display scaler chips. So we partner on software. We have partnership with Google, where we have launched Chromebook Plus leadership flagship Chromebook Plus devices with on-device AI capabilities in partnership with Google. So we have software partnership. And third is we think about go-to-market partnership. Where is the right channel partner that we can work with? And we have partnerships with our retailers and reseller channels to drive an effective go-to-market across many segments, including PC, IoT, and others. So partnerships and ecosystem engagement is core to our development all the way to launch, and we look at it holistically.
Great. Thanks a lot for answering all my questions. This was really fun.
Yeah, for sure, Anshel. Thank you for having me here.